Yeah, very excited for the talk. Thanks for being here.
Thanks, Johannes, for the introduction. And I want you to be aware that I'm going to record this. I'm actually already started recording this on my Zoom channel so that I can upload my talk to my YouTube channel after this. And that means that you also don't need to take notes. You can just watch it afterwards if you like. And also that means that if you ask some question, it's going to be recorded. And if you don't want that, then just let me know so that I can either delete it or edit it out afterwards. And also that means that I don't shout or say something inappropriate. All right. So as Johannes said, that I and Hayato actually met in some summer school in 2015, and then that was the kind of start of this whole project for me. And I want to talk today. By the way, the title of the talk is Quantum Qualia Structure Paradigm and the Quantum Qualia Hypothesis. And this kind of enigmatic animation will be a part of this. And I'll talk about this project, and then secondly, the most significant outcome of the project so far, which is this structure alignment. And then finally, I'll talk about the unpublished hypothesis, which we call Quantum Qualia hypothesis. So the first one, basically, so this part is a bit of the advertisement, a bit changing. We recently received some relatively big grant from Japanese government, and that was for 5 years. And the name of the project is Qualia Structure Project. And ultimate goal of this project is to establish a super interdisciplinary research program to do this, consciousness research basically. And then we'll have some postdoc positions and also summer school. Potentially, maybe I want to collaborate with you guys to do this in cabin thing. Potentially,
Yes, please.
Yeah. Sounds good. So that's my plan. I think this, atmosphere here, and so the people around here is really fantastic for this purpose, really. So this is the 13 PIs involved in this project, and as you see, Hayato and Steve is another couple of theorists, and Shigeru and also you are phenomenologist, philosopher. And Morgan-san and Hasan is a development, and these Yamaha-san and is neuroimaging, and Matsuda Ozumi, who I'm going to talk about his work today. Is so computational neuroscientist, and Hori-san, Tani-san is robotics AI people, and that's kind of related to this ChatGPT and consciousness kind of issue. And then San-san is also working on linguistic. And so far as I know, linguistic and also consciousness study has been quite much divorced. But many people probably start to think about the marriage of this through the ChatGPT, and we are, in a sense, right on time. And this is a previous version of this, Qualia Structure grant, smaller scale, but we have this, number of students and so also involved. So the Qualia Structure wants to do several to address several questions and to establish several paradigms. One of the key questions, fundamental questions that we want to address is, of course, this question: do we experience blueness in the same way as us? Do I experience the same way as you, or whatever, right? That's that came up with yesterday's discussion if you were here. And my question is that can we make it scientific? By scientific, there can be many different kind of definitions, and we can also discuss it later. But my answer, I'll tell you later. And also another related kind of question is, can we establish a gold standard for consciousness research? And by that, what I mean is that, as you may know, if you go into the review paper by Tim Bain and Anil Seth, or any kind of review paper on the theories of consciousness available, Johannes told me that he and Tim counted number of the theories, And how many theories do you think you
That
have?
was Jonathan just asked.
Jonathan, yeah, how many theories or consciousness right now do you have? Do you think you have? Except, minor variations like IIT 1.0, 2.0, 3.0, that's just, one. But, just counting a distinctive theory, how many do you think? 5?
7.
10?
30.
30?
36.
36, yeah, exactly.
That's exactly right.
But because he cheated. He watched my YouTube video. We discussed.
Okay.
Anyway, so the problem is that we don't have right now any way to actually compare these things actually. And there are adversarial collaboration schemes that's going on supported by Templeton Foundation, but every time they try to compare it, even one of the two most quantitative theories like IIT and global neural workspace, it's so hard to come up with a prediction and also hard to come up with a paradigm that can test these two theories, and that goes for any other 34 other theories actually. And the reason I suspect is that there are no gold standard at the level of the Qualia side. I think you or somebody else pointed out yesterday that there are lots of theories about physical side, brain side, but almost zero mathematical theory or quantity on the Qualia side, right? And then if you are proposing a theory that tries to connect between the two, because this side is none, you can't actually collapse anything into here. So I want to what I want to do is to establish this side, constraint on any kind of theory has to at least explain, and that's the sort of what we try to do. And then yeah, all right. So the first part of this Qualia structure paradigm originate from this idea actually. Yoneda lemma inspired characterization Qualia. Yoneda lemma, I'm going to explain if you don't know about it. So Hayato and Shigeru are the one that I met in 2015 and summer school, and then we wrote this paper just like in 4 days or something after inspired in this. And then after that, we have been proposing this more formal version, but more to do with the introduction of this relational approach to consciousness. And then follow that with the enriched category version of the same claim. So if you're really concerned about whether the category theory can be just binary or continuous, then this is the version I think I recommend. And then recently we also introduced the concept of adjunction that hasn't been talked so much in even this conference, but I think it's really important. And in fact, Toby's yesterday's talk on shared consciousness is probably to do with adjunction actually. We are talking about the same thing, like blueness or redness, but not exactly the same. But it's same enough to share the experience. And this also relates to the pain kind of discussion yesterday. I don't know exact pain that you have, but I'm pretty sure that it's not like a tickling or ecstasy. So that's enough, for the adjunction. All right. So this Qualia structure paradigm idea is that we can characterize something that is very difficult to do through the relationship. So typically, if you read the for example, writing by Daniel Dennett and so on, who claim that we can never ever do science on Qualia. First thing they say is that because the Qualia is an ineffable, right? When you try to describe my red or my purple, and then all I can say is that this purple is kind of similar to the gray, grape that I had yesterday or something like that. And no matter how much time I spend to describe this particular grape, I just can't deliver it to you with my satisfaction or your satisfaction. And that's the sort of ineffability, I think. But something like this happens actually across many different fields outside of the consciousness, actually. Like the meaning of the word that was first pointed out by Fernando Saussure. he said basically that meaning of the word is not something that you can actually describe by definition perfectly, but it's only through the relationship with the words, and so when it's embedded in some particular context, then finally the meaning gets fixed. And similar thing happens also with the the property of the animals or plants. If you can of course isolate all these things and then study its property, but it's meaningless completely, right? Because it's only meaningful to characterize that in an actual ecosystem and also interaction with other things. And even mathematics or physics, black holes or infinity or something like that is also characterized through the relationship with others. Not black hole you can't observe directly, but its relation with other objects is possible to see. And a personality, like you can also describe me, like the definition red points of now its personality, like he's like this and or whatever. But also, you can describe myself with, I have a friend like Hayato or whatever. So that's the idea. And then one of my biggest surprise when I encountered in category theory is that there is a theorem that actually proves this, and I was like, why didn't you tell me? Until then, if I had that solves many of the problem in consciousness research actually. But of course, this equation is super difficult to understand for the neuroscientist and psychologist, so that's impossible. But I got Hayato explaining me as a sort of idea, and that's definitely there, right? And the consequence or the consequence of this the lemma is that HA, which you can read as a sort of all the relationship between A and other objects, and all the relationship between B and the other objects. If they are the same, then A and B has to be the same. And that's the sort of the idea that is captured by this movie that we made. I mean, my student actually made. And so, if you don't know, or if you just can't characterize what A is itself, but if you have a huge number of the relationship, it just gets fixed. And that's the idea. All right. But I also should be careful about this. So this actually works if the A and B and the other objects are forms category or image category. And if they don't, or under some certain kind of condition, then this also doesn't also work as well. So all right, then using this idea, the next thing is to start doing empirical science with this, and that's the Qualia structure alignment experiment. And this is done most importantly, Genji Kawakita over there. He was the gun, you are still like a research assistant before starting PhD to do this, right? And so another bachelor student, Ken, is also critically involved in this. And my collaborator Masafumi and my postdoc Ariel did collection of the data. So the structure approach to the Qualia is first we want to do is to identify or characterize Qualia structure of one person. Right? My red, what it's like in relation to other experience. And then if person B also has another kind of experiential structure, we can potentially quantify the degree of alignment between them. So that's a sort of the focus of the talk today. But eventually, within 5 years of this Qualia structure program project, what we want to do is above and beyond this functional characterization, which is this mapping between this particular Qualia structure has to come from this information structure. And in analytic terms, it's a cause-effect structure. If this mapping is possible, then we can also do this in a sense, for the category theorists, it's a commutative diagram of the Qualia and information structure. You can go from here to here to here to there, or from here to here. If that's possible, I think that's really fun. That really fundamentally changes the science of consciousness. You may claim that my pain cannot be shared at all to you like this way, Yeah, sure, but I actually can measure your brain and can determine your information structure, and then I can transplant, your pain, which I don't want to do, to my brain, and then I can experience your pain, not as a sort of sympathy or empathy, directly experiencing it, right? So that's the idea. So then the question is that how can we obtain this Qualia structure here, and so how can we align Qualia structure here? And the structure of consciousness-wise, I first introduced this estimation of this structure through a massive collection of the similarity ratings. That's the first step. And I'm not saying that the similarity ratings between Qualia exhaust all the relationships. There has to be something like an inclusion or also the intensity, comparison and things like that. But let's really start with a very simple, relationship. The paradigm-wise, it goes like this. So you see the central fixation point, and then we show this color patch at a random location very briefly, 250 milliseconds. We can't expect the location and also color and also angle. And then afterwards, I use report how similar it was from 0 to 7. Yes.
Just a question to something that you said when you said that when you transplant this then into your brain, you could kind of experience the same feeling. You mean by actually putting electrodes into your brain?
Electrode or optogenetic, maybe.
Okay, so by really creating the state in your brain as well.
Exactly.
And then.
Yeah. All right. So fine. And then, to come back, then we show it, we flash it, and then we do this, rating of similarity. And in reality, it looks like this. And the point here is that some people may doubt that we can't experience a color in the periphery, but that's not true. Some philosophers said that and claimed that, but that we prove that it's not true. And then that's publishing here. We even registered the report. So if you're interested, please check. Anyway, so then using this, what we started to do is to distribute this similarity rating across many people. So rating-wise, for a given subject, you can't do this, 10,000 trials, right? Unless you're masochistic or a dictator. And so what we do is to go to the online platform and ask people to do this experiment randomly chosen from this gigantic matrix. But we employ a lot of people. This is just like 250, but by now over 1,000 people have kind of contributed to this. But interestingly, roughly like 10, 100 or 200 subjects will be enough to get a more or less reasonable result actually. So the standard, idea about this Qualia alignment, you might think is something like this. So I have a red, and I have a purple, I have a blue. And then I want to directly, compare your red, your purple, and your blue. And then just try to, look at sort of similarity or correspondence or measuring distance. But we claim that this is a really bad idea because, it's presupposed that, we have a kind of matching kind of label already. So instead, Masafumi and also, Genji's idea, it's not mine, was to use this unsupervised alignment kind of idea. So we derive some form of a transformation matrix so that my red can go there or go even in the non-existent location, and then see whether that actually happens to be the same with your red or not. So that's not cheating, right? We don't have any information about your structure, the labels. We know that we are shown the same set of stimuli. But we don't know whether that corresponds to any of the particular query. That's a program setting. Okay. Then, in terms of mathematics, it's kind of interesting that this is a kind of mathematical consciousness sort of a conference, but we don't get to see much of the equation so far. But here, this is a real equation actually. So what we do is to compute the distance between all the items within Qualia structure 1, that's Dij, and then subtract that with any, all the combination of DKL. And then square it, and then multiply by this, enigmatic matrix called gamma. gamma ik and gamma jl. And then this shows that it's a minimization of this kind of matrix that result in this minimizing this distance over this all possible gamma matrix. It's very heavy in terms of computation, but if the matrix is very small, you can actually exhaustively compute all the possible permutation. And Genji and Masumi has looked into the literature and then found some kind of very nice algorithm that does that really quickly. So that's the reason why we can do it now. So just to remind you, so the rule is that without using any color labels, but we know the relationship between them only, and then we try alignment, and then see whether that actually match or not. So that's the sort of idea, all right? So this is a similarity matrix of 93 colors. And so to make it sort of fair, I removed all the labels of the 93 colors. And then this is a group 5 and group 6. And each group is roughly like 100 people's similarity matrix. And then this is a so-called multi-dimensional scaling representation of this color similarity. So it's a 93 dots all over. And then to try to kind of keep the distance relationship between points. That's similarity. And as you can see from here, there's some kind of cluster over the top left, and then other parts are very messy, and it looks more the same, right? And then also, if you look at this structure, it looks like 3D, and it looks kind of reasonable. Sure, okay, maybe how can we do that? And then it turns out that group 1 to 5 can be almost perfectly aligned from here, which is complete mess, into really reasonable kind of structure alignment. And that's the sort of alignment procedure. But it turns out that group 6 we failed completely miserably. We can't just align it. But that's actually good news, because the group 6 is coming from a color atypical deuteronomy. So those people are the ones with online tasks we detected the red-green discrimination is very bad. And they declare that, and we did some kind of online clever check physically, and then their structure actually turns out to be not possible to align with our color structure. That serves as a very good sanity check, actually. So if you pay attention to this, MDA structure, actually you see that green points are here, and the red points are here, right? But this deuteronomes people's green and orange is next to each other, and sometimes this I'm color typical, so I find that this sometimes this arrangement to be weird, but that's not. It seems not weird for them, right? And also interestingly, for them, something that is very different is something that I find is very similar. So there is some kind of probably trade-off between sensitivity to one direction and not the other. So this is before our study, like in '92, Shepard, who is a big guy in psychology, did all these similarity experiments and found that color deuteronomes structure is like this. And then when I read that paper, it didn't really, I don't know how to say it. It didn't make sense, or it doesn't allow me to imagine how the color experience is like. But this one, I feel like it's more possible to imagine what it's like to be colorblind. It's not, definitely, one dimensional, two-dimensional grayscale. It's complex on its own, but there is some kind of confusion over them, some kind of green and some kind of red, right? So, and then the way we actually characterize is so-called top K matching metric. So if you pick one particular color, and then for the other group after the alignment, if you pick the best matching part, or top 3 or top 5 or something like that, it turns out that within normal trichromats, it's very accurately possible to align between the two structures. So according to this, I can be quite confident that I see the same the blue as you would if you are not, colorblind, right? But if you are red-green color blind, then I just cannot do that. It's almost a chance performance is like 1%, but so it's much better because there are some colors that actually do align, but for some in terms of structure, it's not that easy to align. It's not trivial if you look at this similarity matrix actually. In terms of a similarity matrix, correlation matrix coefficient between these two are like 0.5 and 0.6, and this to this is 0.5 or so, right? Yeah. So that standard, sort of similarity analysis doesn't really, distinguish the structure, and that's totally, reasonable, right? Because what we want to know is a shape, but a similarity matrix is like a kind of very simplified and stupid, matrix, representation that can be confounded by many things. All right. So the Qualia structure project so far, the other lemma inspired characterization of the Qualia to theoretical proposal, and then we try to implement this measurement online, and then we were now kind of coming to this aligning of the structure without labels. That's the sort of the summary so far. And then before going further, maybe let me go to this next step on the ongoing project, and then take some questions at this stage, and then I'll also talk about Quantum Qualia after. So that one that is actually included in this preprint paper is that use of this object thing data that has 1,800 objects and 1 million people's data, and that we can actually align really good as well. And then we started doing the topological data analysis. And if you have any kind of expertise, I actually want to get opinion, because we have a result we can't interpret really well. So that's something. And then aligning across developmental stage, culture, and modalities, vision language, and so on is the next step that we plan to do. Because many claims has been made before, right? Like language determines the experience, but is it really true according to this kind of paradigm? And also, we are almost finishing this one with or without calculation, whether we can align the structure or not. And I think it's actually much more interesting compared to the psychedelic or meditation, like outer state of consciousness, which was discussed also yesterday. Partly because with or without attention is something that we can all do without any drugs and without any practice, and then we can just verify it really easily. But these are kind of special treatment that we need to do. Yes.
When you say with or without attention, just like the level of intensity of the attention you're directing to students?
Yeah, so there can be many ways of doing it, but what we did was to present that kind of color patch or something like that at the diametric opposite location while you are doing the very difficult task at center, or ignoring that and then just doing that only. Some of the structure change, some like rotated letter similarity, but face gender similarity doesn't change and things like that. Yeah. All right, and then also Genji is now doing something with the ChatGPT, and if you're interested, you can ask him about the results. And also applying to other domains, we are also looking at the emotional qualia. So there was also something discussion yesterday that also originates in the phenomenological or gestalt psychology kind of tradition, saying that our sensation can be shared as long as stimulus is controlled and fixed, but emotion is never possible to share because it's so subjective and so subject to interpretation and history and so on. I strongly doubt about that, and we are doing some experiments like this. And so the question that we also want to address in one of the fundamental questions, which hasn't probably properly addressed, is why colors feel like colors. or unlike taste, or unlike smells or pain. And this probably requires some kind of category theoretical kind of thinking, I think. So far, you could stick with a set theory like, idea of red to red or red to purple or something like that. But once you go to this category level, like, why color, color experience category is so different from taste category, experience. Probably you need to go into natural transformation or, at least functional level, right? So that's the idea that I want to pursue. And then the gold standard challenge. So if we put this, the data is I think already online available. And I want to challenge, if I have, huge amount of money, maybe, then I would ask, each of the 36, theory proposer to make any kind of prediction or explanation of why we get this. As far as I know, probably IIT may be able to make a little bit of the explanation like this, but I don't really know what other theory would say about, this kind of, question. Okay. So, so far, fine. Is there any question?
Oh yeah, so I just wanted to ask how you want to do it. So do you want to have a quick question block? Or
Yeah. Or maybe we can.
It's up to you. So we have to finish by 20 after, including questions.
Okay.
So it's quite a bit of time,
But yeah, so far, is there any question?
I have a question.
Yeah. Kobe.
So one technical question, but so you said that this was inspired by the dilemma. In terms of what you showed, it sort of seemed more like we have two maybe metric spaces, or you're trying to. I mean, I didn't see so much category theory. We see more like symmetric notions. Is that?
Yeah. So this is a more precisely on the level of the enriched category theory, using the notion of the distance like thing as a similarity, and then to apply the unit lemma in that version. But also, I agree that it's also not that we can't directly compare, or we can't draw the arrow of my red to purple, and your red and your purple. So that's not really exactly like unit lemma like concept. So it's I'm just saying the unit lemma inspired.
Okay. Yeah. And by the way, I'm red green.
I see.
But just about the last kind of gold standard. So you mentioned something about ChatGPT. So it's possible that kind of completely two different realization brains. So let's say one which is very human-like, for evolutionary reasons, maybe, or other reasons, developed in this direction, and then like this artificial brain that for other evolutionary reasons actually completely different. When you do this, you get similar experiences, but completely different architecture. So any IIT, GMT, whatever kind of will just. I mean, where would the gold standard come from?
Yeah, you're absolutely right. That at the level of only functional behavior reports, ChatGPT and so us and Octopus or whatever can report the similarity rating and we can align or not. That's totally fine. But what we are saying is no, that is the proof that I'm seeing the red as the GPT is seeing the red. And we never said that. It's only within humans, within normal, and then whether we can align this or not. And so that serves as a sort of necessary condition to compare within human, where we can accept that they are already experiencing qualia. But if you go beyond like different kind of creature, then as I said, like IIT kind of scheme, we need to go between the Qualia structure to the neuronal structure or something like that. I'll just it will probably take time, so I'll just don't go that. But we need to do some kind of commutative diagram. And in my opinion, we don't really know that GPT's information structure to Qualia structure. I just don't have any kind of answer. And whether there's anything we can sell, I don't know.
So Chester, before we go on,
Yeah.
how much time do you want to have to finish the talk?
So you said that including question 20?
Yeah, we can finish 20 after, so like, do you need 10 more minutes?
Maybe let's take really short question, like 2 more.
Yeah.
So.
Just one suggestion, in connection with these estimates of Qualia similarity
Right.
via the, something which it might be very well worth looking at, and you may have already thought of this, is looking at, see whether these are affected in the case of speakers of languages where there is a different system of communication. But I mean, this is probably notoriously in Russia. In Russian, purple is actually treated as a shade of blue. And it would be interesting to know whether that affects the subjective estimates of Qualia similarity.
Yeah, I agree. And we plan to do that as well.
You are. Okay,
Yeah,
thanks.
yeah.
So this is really cool. So if you're treating Qualia as being like via the Jungian lemma, like these like free sheaves basically, then that category has like a lot of additional structure also because of the topos. So you have like a lot of other things, like you have products and co-products and like HOM objects and stuff like that. So if you looked empirically to see if like you, for example, if you have like a product object that you would expect in this category, like a combination of 2 colors that like what you get in terms of like the overall similarity matrix actually aligns with like the prediction that you get from the enriched category theory as far as that like free sheaf basically.
That sounds excellent, and I don't know. Well,
Yeah, I think so.
okay. All right. Maybe last quick question. If it's quick. Yeah.
I don't know if it's so quick, but
Oh.
Question.
Yeah.
So Unit Lemma tells you that a category embeds faithfully in its category sheet already. Okay. But the opposite is sort of not true. So if you have 2 perceived categories, so let's say like categories here are like the actual qualia and their structure, and then species over them are the observations you make of that, right? And so say now you found an alignment between pre-sheaves categories, like according, so that's like, okay, they tell me something about the quality of say. But then if I have 2 perceived categories that are isomorphic to each other, doesn't mean that the 2 categories are isomorphic. This is called Morita equivalence, of a weaker form of equivalence of categories. So it might be that we're like observationally equivalent, but then the underlying structures are not. What do you make of this?
It's good. And we first go this multi-equivalence like similarity, and then go further with discuss notable. So it is our first step.
Yeah.
Okay. So then let me move on, and then if you can take.
Just have a little question.
Yeah.
Maybe it's a food for thought. Don't you think that your gold standard proposal, which is of course a very honorable aim, is a bit skewed because you reduce the problem of consciousness and predicting and having a predictive framework for consciousness to the qualia issue, but there's also constitutive aspect. There is pre-reflective consciousness. So I think that what you do here is not encompassing enough of consciousness to be called a gold standard, except if you frame it in a specific context. But that's
okay. Maybe we can talk about it later. But my short answer is that I think this is a central question, and without if you can't address this question, then you may be ending up with something not really directly central to consciousness. But anyway, we can discuss it later. All right, now change a bit of the pace. Shall we take a break? 1 minute or maybe not? Okay.
No break. I think just go on. We have to finish so we're already running late for first talk, so we have to finish at 20 after.
Yeah, okay. So the second part will be relatively short. Okay, so that's a quantum Qualia hypothesis. Some of you may be actually more interested in this one, but it's less developed actually. So what are the mathematical structure of Qualia? And one of the things that I kind of implicitly assumed in the last part of the talk is that each Qualia color experience is definite. And the definitive experience is usually, and most popularly, modeled in psychological literature using these points in high dimensional scale space. The color is most famous cases, right? This is a 3-dimensional representation of this MDS coordinate. But and this has been done for using color, sound, object, emotion, olfaction, or art and taste and smells and so on, based on similarity among these objects. But if you introspect your experience, let's say like the boundary of the vision, this is sometimes referred or invoked in IIT writing actually. But if you actually try to know where your vision stops, when you're opening your eyes, you can kind of use your hand and then tell, maybe like this, right? But at the moment that you don't do this, it becomes very unsure. And even worse, if you close your eyes, then is there any kind of boundary for the vision? I really can't tell, right? And also, a feeling of touch is important. When you see this, you probably start to feel, I have something. But before that, it's plausible that you may not have it at all, or very vague kind of sensation, right? Unless you have some kind of ulcer or whatever pain. But this doesn't mean that you didn't have anything before that, right? And was it there all the time? Did it change when you are there? So my part of my previous research topic was on the relationship between consciousness and attention, and it has been always a big kind of psychology, neuroscience kind of question. And thinking about this, all these colors and so on as a points in space feels a bit, kind of unsatisfactory. Maybe you can blur all of the colors with a Gaussian or whatever. It's not really, good for me for several reasons. So the design property of the Qualia models, I think, is that the Qualia can be treated as an indeterminate phenomenon, and then like order of experience in the space and time, and also the case of the without attention or the case of the threshold phenomenon. If you show something very briefly, and you definitely felt something, but you don't know what it is exactly kind of situation. And also the interaction with attention also kind of implies that the Qualia is not a static phenomenon, but this point in the high-dimensional space does imply that it's a snapshot of experience and it is static, right? But it's probably not. And multi-stability, like a negative and binocchio rivalry also implies that it has to be explained in a dynamic framework. And as I said, not only attention, but sensory inputs and memory are definitely constitutive of our conscious experience. So the upshot of this hypothesis is this figure actually. We consider Qualia as an observable and so core of experience that we can directly experience. And that's the only thing that I have for my Qualia. And then I can interact with the world, but through the membrane or interface. Like Hayato said that yesterday, that the states are the kind of membrane or interface between my Qualia to the world. And then if you think it that way, then these things seems to be able to capture. All three components can be captured. And I'll go one by one. So first, Qualia as observables and processes surrounding Qualia as processes and states. And this observable states distinction is probably important. And then the second is that Qualia and states interact in an evolve in an interaction picture of the quantum theory. I will explain it a bit later after explaining this one. And then dynamics of Qualia can be also captured through the framework called instruments. And that's the little equation here. And Masanao is going to talk about that after my talk. So I don't go into the complex issue of this one. I look forward to his talk. So unlike the very traditional kind of attention consciousness framework, which is like sensory input and the attention filters relevant information, and that becomes your Qualia and then to be reported. This kind of form kind of model has been kind of discredited by many experiments so far. And I've been proposing something like this: sensory input can be attended or gives rise to consciousness, and then part of that is reportable. But that's also still like static. And this one, I feel it's much better now, and that's the proposal. So the inspiration came from this program called the quantum cognition. And the quantum cognition had started around like 95 or so. Diederik Arts, who actually learned to know that Bob Cook's supervisor in his PhD, started to do something like this, like an application of quantum theory, from a quantum probability theory to be more specific, in the field outside of the physics. And then other people like Atman Stocker in the field, and also Andrei Krennikov also started doing this kind of application of the quantum probability theory into psychology domain, especially. And especially the decision making and also causal reasoning and things like that, where many people studied, but result in a very counterintuitive or illogical finding, has been studied by Jerome Busemeyer and my collaborator Peter Bruza. And that book inspired lots of interest. And then recently, my also another collaborator Emmanuel Posos and Jerome wrote this quite nice authentic review in the annual review of psychology. So it's going really hard. And one of the for example of this quantum cognition is the explanation of counterintuitive property of the similarity. So if I ask you if China is similar to North Korea, then most likely you say, no, that's very different country, right? But if I ask you, is North Korea similar to China? Then suddenly you feel like, yeah, maybe there is something similarity, right? And this has been discovered by the laureate and Daniel Kahneman's collaborator, Tversky, saying that similarity experience is actually not really commutative. Distance between A and B is not the same from the distance B to A in general. And this is very difficult to explain with a classical, logical, psychophysics framework. But quantum cognition can actually do that. And the way to do that is, I'll just skip this kind of projection scheme. So if you define the similarity as a sort of the double projected length of the vector, and then if the two vectors are similar, this projected vector is very long. That means that it's very similar. But if it's orthogonal, it's minimum. That's the similarity. And this framework in general can explain this kind of order effects. So, maybe I should actually change the order of this thing. But anyway, to come back to this, observable states and measurement outcomes, real quantum theory has something like this. Observable is algebra, is the algebra. And then states are unit one vector in Hilbert space, and then this average measurement outcomes is represented like this. And then quantum cognition framework uses response options, like saying yes or no as an observable or axis, and that can be either orthogonal or incompatible with another set of bases. And because of this, the difference in bases in a low dimension space, there can be weird heuristic type decision happening. And then they think about mental states as a kind of moving state vector. And then we get a response. And what we are proposing is that the Qualia itself as an observable, and that also changes all the time, depending on the input and also interaction with attention and so on, and that the states are sensory inputs and attention and other elemental processing that sort of forms or constrains what we actually experience. And then that's sort of our new framework. And then briefly, just two ways to test whether our hypothesis is actually plausible or necessary to involve to explain Qualia. One is this, systematic explanation of the order effects in the Qualia judgment. So as I said, China, North Korea example has been, involved, lots of discussion, but, it's always like, peculiar example, isolated example. But in the case of the color, we can examine this in a very systematic way. And in fact, if you do this, one patch presenting first and then second patch presented later, we get this type of similarity matrix. But if you examine each pair very carefully, sometimes you do see asymmetry and in a reliable and statistically significant manner. And how come these things comes is not super easy to explain with a classical model with a little bit of Gaussian noise, right? And we indeed, try to compare the performance of a model where we explain that each of the color experience as an array or subspace of a three-dimensional space versus points in a three-dimensional space plus some kind of arbitrary classical explanation of asymmetry. And then it's this one is massively better in terms of Bayesian information criteria and so on, because we don't need much extra parameter to explain this asymmetry actually. So here just like a cartoon version, initial state vector, thinking about first orange and then a red, result in this level of similarity. It's not that similar. And then if you think about red and then orange, it's very similar. So that's the sort of the mechanism to explain how this order effect comes about in the quantum equation framework. So in a sense, one of my goal would be like Genji's alignment kind of experiment or analysis with this kind of space. That would be probably necessary to think about other types of Qualia, which would be more influenced by the order effects other than color. Second method to test whether our hypothesis is valid or not is this violation of the Bell-like inequality. And this is also much more interesting in a sense for the physicists actually. So if all the method property is like a set theory like if I ask X and then you say yes or no at certain probability, then your probability can be described by this Venn diagram, right? And then probability of you saying yes to all of three questions will be like the center. And then if you ask like a probability of, I present one stimulus like single dot, that could be red or blue or circle or triangle on the left or right position. And then if I just compute the probability that you say yes for each of the three questions, then we can get this Venn diagram. And then if I ask two questions at a time, but in three different conditions, then that becomes the test of the violation of the inequality. Well, what I mean is that if it's probability of red is like this much, like 0.7, and then probability of red and circle is this much, and the probability of red on the left, probability of circle on the left, you can measure three different conditions, right? Then, if you're really speaking with classical, logical kind of structure, then subtraction of these two plus addition of this has to be always like this and above zero. And if it becomes negative, then there must be something wrong in your assumption. And that's basically the violation of the Bell-like inequality. And in fact, if you, I was actually quite surprised to see this because I'm not a physicist. This actually happens physically in quantum effects in real life macro scale. If you use a polarizer of 0 degree and 90 degree, they completely block the photons. But if you insert a 45 degree polarizer in between, not before, not after, then you pass more photons here. And this never happens under this condition. And this is the Bell violation. It's form of the violation of Bells. And again, projection kind of scheme can explain this. And Peter Bruza recently found that this kind of thing actually happens for perception. And critically, almost no, as far as I know, almost no consciousness research asked two questions of one object, which has more than three properties at the same time, and then in three different conditions. So who does that? Because without any theory, you don't know how to interpret it, right? So that it's really one of the very rare situations they did it, and then one of the two phases indeed violated that. So if you ask trustworthy and then dominant, or dominant and then intelligent, and then trustworthy and then intelligent, if you compute this to the probability, then it just violates. And the implication is that the property of the trustworthiness, dominance, and the intelligence in some way is indeterminate. The moment you make a judgment, it kind of influences back into your experience, and that forms your qualia. So that's our interpretation. And we need to do more experiments like this, but that's the indication. So this is the last slide. So if we establish this, then outputs of the maybe I'll just skip this one to just get your feedback or question, and I'll leave it here.
Okay.
Thank you.
Now you pick questions, and we have 4 minutes to go.
All right. Maybe Paul?
Oh, thank you very much. I really enjoyed that.
Thank you.
It triggered me as a psychologist. I had three things, so I don't want to hog the time.
Maybe then one.
Yeah, well, one very brief one is that there seems to be a similarity between your view and the distinction between phenomenal and access consciousness. I don't know whether you picked that up or got anything to say about it, but that's a minor thing. You're talking about the order effects of making discrimination, and these things have been known in psychology for a very long time, even in psychophysical experiments, where basically somebody's making the same decision over and over again. There are sort of sequential dependencies and responses that have nothing to do with the whether there's something there or not, essentially with the qualia themselves. So again, that's a sort of an access process, and that might have something to do with criterion setting, management of the internal threshold, where somebody is making a response or answering the question about whether there's something there or not. So that sort of thing could be happening when you're asking somebody a question like, are these two colors similar?
Yeah, so
and so there could be an analogy between, the classical way of setting criteria in making yes, no, or judgments, and quantum entanglement.
So the question is whether we can actually explain the cell, order effects or any other effects that we find with the classical, model plus alpha, and it's plausible, definitely, and especially, this quantum effects is always possible if you invoke some kind of conditional probability kind of argument. Under this condition, you get this. Under this condition, you get this, and so on. It's like, for me, it's like a Ptolemaic kind of view. In the end, you have a huge number of parameters to explain everything, and if that's not going to that direction, like fewer parameters, and then we explain this effect, I'm happy with the classical explanation. However, it's probably going to be difficult, my guess. We did best effort to do this case or comparison between the classical version versus quantum version, but the quantum version was much better. So all right, back. Sorry.
I was wondering, when you showed this inequality, I was always thinking about the hidden variables that can be. So normally when you have these inequalities, what you are testing is against a hidden variable.
So
do you have any what would be the variable is if we are trying to.
Yeah, so that especially this version of this test, value inequality test has been, of course, invokes the hidden variable kind of explanation for especially for among physicists, right? And we actually don't think that standard bell type kind of explanation will be possible because in psychology,